Dear student, today we are going to learn the fourth topic of Science 1, and that is effects of electric current. In the previous standard, we have already learned the static electricity and current electricity. Static electricity is produced due to friction. Due to friction, the object becomes positively and negatively charged because of transfer of negative charge from one object to another object. As this charge does not flow, it is called static electricity. And if the electric charge flows through a metal wire, then it is called current electricity. The material which carries electric charge from one end to another is called conductor, and the material which do not carries electric charge from one end to other, it is called insulator. Unless and until the electric potential difference is created between the two ends of the wire, the electricity does not flow, and hence to provide the potential difference we connect the cell between two ends of the wire. In this chapter, we are going to learn the electric current flowing through the wire, the electric current flowing through the resistor, electromagnetic induction, and the working of electric motor and generator. All these are the effects of electric current. So first, let us start electric transfer in an electric circuit. Energy transfer in an electric circuit. If the wire AB of resistance R is connected in a circuit, the cell provides energy. This energy provided by the cell to the resistor get converted into heat energy, and because of which the temperature of resistor is increased. If in the circuit the resistor is replaced by a motor, then the energy provided by the cell get converted into mechanical energy. The heat energy produced by the cell in the resistor can be calculated by the formula H is equal to I square into R into T, which is also called Joule's law of heating. So remember the formula H is equal to I square RT. The unit of heat is joule or calorie, and the unit of electrical power is watt, which is also called joule per second. But watt is a very small unit of electrical power. Therefore, in day-to-day practice, kilowatt unit is used to measure the electric power. If you see your electricity bill, there you will find the electricity bill is specified in terms of units. What is mean by unit? If 1 kilowatt power is used for 1 hour, then it is called 1 kilowatt per hour or 1 kilowatt in 1 hour, which is equal to 1 unit. That means 1 unit is equal to 1 kilowatt hour, which is equal to 3.6 into 10 raised to 6 joule. Now we are going to learn heating effect of electric current. When a resistor is connected in an electric circuit, then heat is produced in it due to electric current. This is known as heating effect of electric current. The instruments like boiler, that means water boiler, electric cooker, electric bulb, make use of heating effect of electric current. In this instrument, electrical conductor having high resistivity are used, which are in the form of coil, which is made up of an alloy of nichrome, which is also called nipermag, which are used in the coils of heaters and electric cookers. While in electric bulb, tungsten wire is used. Because of electric current, this tungsten wire get heated nearly up to 3400 degrees Celsius, and at such an high temperature it start emitting light. and to some extent it also radiates heat. आता आपण थोडक्यात आपल्या घरातील इलेक्ट्रिकल कनेक्शनबद्दल माहिती घेऊया. The home electrical connection consists of three wires. One of it is live wire, the second is neutral wire, and third is earth wire. लाईव्ह वायरमधून करंट घरात येतो, न्यूट्रल वायरमधून जास्तीचा करंट परत जातो आणि अर्थिंग वायर ही इलेक्ट्रिकल शॉकपासून प्रोटेक्शन करण्यासाठी असते. लाईव्ह वायर आणि न्यूट्रल वायरमधील पोटेन्शियल डिफरन्स असतो 220 व्होल्ट. जर इलेक्ट्रिकल इक्विपमेंटमध्ये काही फॉल्ट झाला किंवा लाईव्ह आणि न्यूट्रल वायरचं कोटिंग हे गळून पडलं तर लाईव्ह आणि न्यूट्रल वायर एकमेकांना टच होतात. When these two wires come in contact with each other, then large current flow through it and it produces a tremendous amount of heat. If any inflammable material such as wood, cloth, plastic is around this place, then it catches fire, which we call it as a short circuit. मुलांनो लक्षात घ्या, शॉर्ट सर्किट होण्याचं कारण हे लाईव्ह वायर आणि न्यूट्रल वायर एकमेकांच्या कॉन्टॅक्टमध्ये येऊन खूप सारा करंट फ्लो होतो आणि त्यामुळे हीट प्रोड्यूस होऊन त्याच्या ठिणग्या पडतात आणि मग खाली जर इन्फ्लेमेबल वस्तूंशी त्यांचा कॉन्टॅक्ट आला तर आग लागते, ज्यालाच आपण शॉर्ट सर्किट असं म्हणतो. आता आपण फ्यूज वायरविषयी थोडी माहिती घेऊया. द फ्यूज वायर इज यूज ॲज अ प्रिकॉटरी मेजर. म्हणजेच घरातील इलेक्ट्रिकल इक्विपमेंटचं नुकसान होऊ नये. केव्हा त्यांचं नुकसान होतं? जेव्हा त्यांच्यामधून खूप सारा करंट वाहतो, त्यांच्या परमिसिबल लिमिटपेक्षा जास्त, तेव्हा ते इलेक्ट्रिकल इक्विपमेंट्स खराब होण्याची शक्यता असते. परंतु फ्यूज वायर जर असेल तर ॲज सून ॲज हाय करंट फ्लोज थ्रू द फ्यूज वायर इट मेल्ट्स अँड ब्रेक द सर्किट. आणि त्यामुळे जास्त करंटमुळे होणारं नुकसान टाळलं जातं, जसे की इलेक्ट्रिकल इक्विपमेंट खराब होणे किंवा शॉर्ट सर्किटला मुळे आग लागणे. म्हणजेच जास्त करंट फ्यूज वायरमधून गेला तर ती मेल्ट होते, इलेक्ट्रिक सर्किट ब्रेक होतं, त्यामुळे इलेक्ट्रिक सप्लाय हा शटडाऊन होतो आणि पुढील होणारं नुकसान टाळलं जातं. म्हणून फ्यूज वायरला प्रोटेक्टिव्ह डिव्हाइस असं म्हणतात. कधीकधी उन्हाळ्याच्या दिवसात अचानक संपूर्ण शहराची वीज जाते. असं का होतं ते आपण पाहूया. इन समर सीझन ह्यूज इलेक्ट्रिकल पॉवर इज यूज इन द इव्हिनिंग ड्यू टू होम लाइटिंग, फॅन, एअर कंडिशनर, यूज ऑफ इलेक्ट्रिसिटी इन शॉप अँड बिकॉज ऑफ व्हेरियस रिझन. As a result, excessive current is drawn from the transformer supplying electricity. And if the capacity of transformer is insufficient, its fuse wire melts and the electric supply gets shut down for the whole city. That means such event occurs due to overloading. Different types of fuses are in use. Nowadays, we use miniature circuit breakers, that is MCB switches. When the current in the circuit suddenly increases, this switches opens and current stop. So different types of MCBs are in use. For the entire house, however, the usual fuse wire is used. विद्यार्थी मित्रांनो, आत्ताच आपण पाहिलं हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट म्हणजे एखाद्या वायरमधून इलेक्ट्रिक करंट वाहत असेल तर ती तापते. तसं या आधीच्या स्टँडर्डमध्ये आपण मॅग्नेट अँड मॅग्नेटिक लाईन ऑफ फोर्स हे सुद्धा लर्न केलेलं आहे. म्हणजेच एखाद्या मॅग्नेटच्या भोवती ज्या क्षेत्रात मॅग्नेटचा प्रभाव असतो आणि तो मॅग्नेटिक लाईनच्या स्वरूपात असतो त्याला मॅग्नेटिक लाईन ऑफ फोर्स असं म्हणतात. ही माहिती देण्याचं कारण म्हणजे आता आपण मॅग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट अभ्यासणार आहोत. बिकॉज इलेक्ट्रिक करंट अँड मॅग्नेटिक फील्ड आर रिलेटेड टू इच अदर. म्हणजेच एखाद्या विद्युत तारेतून जेव्हा करंट वाहत असतो तेव्हा त्या तारेभोवती मॅग्नेटिक फील्ड तयार होते. याचा शोध पहिल्यांदी 19व्या शतकात सायंटिस्ट हेन्स ख्रिश्चन ओरस्टेड यांना लागला. He observed that When a current passes through a metal wire, a magnetic needle near the wire start deflecting. आणि यावरूनच त्यांना इलेक्ट्रिसिटी आणि मॅग्नेटिझम यांचा शोध लागला. कारण आत्ता आपण सर्व ठिकाणी वापरात असलेली इलेक्ट्रिक मोटर याचं कन्स्ट्रक्शन आणि वर्किंग याच प्रिन्सिपलवर आधारित आहे. आणि याहीपेक्षा अजून एक इंटरेस्टिंग गोष्ट अशी की जर तुम्ही मॅग्नेट हे हलवत ठेवलं किंवा मॅग्नेटिक फील्ड सारखी चेंज करत ठेवली तर शेजारच्या वायरमध्ये इलेक्ट्रिसिटी आपोआप तयार होते. याचाच अर्थ असा की इलेक्ट्रिसिटी वाहत असेल तर त्या वायरभोवती मॅग्नेटिक फील्ड तयार होते आणि मॅग्नेटिक फील्ड चेंज करत राहिली तर त्या वायरमध्ये इलेक्ट्रिक करंट तयार होतो. आणि याच प्रिन्सिपलचा वापर करून आपण इलेक्ट्रिक मोटर आणि इलेक्ट्रिक जनरेटर याचं कन्स्ट्रक्शन अँड वर्किंग पाहणार आहोत. So student, always remember a magnetic field is produced around a current carrying conductor, and if this current is unchanged, then this magnetic field reduces as the distance from the wire increases. And because of that, the concentric circle which represent the magnetic line of force becomes bigger and bigger as we goes far from the wire. If the current through the wire is increased, the intensity of magnetic field also increases. आता ही मेटल वायर भोवती तयार होणारी मॅग्नेटिक फील्ड कुठल्या डायरेक्शनमध्ये प्रोड्यूस होते हे जर आपल्याला अभ्यासायचं असेल तर आपल्याला राईट हँड थंब रूल पाहावा लागेल. So imagine that you have held the conductor in your right hand in such a way that your thumb points the direction of current. Then your turn finger around the conductor point out the direction of magnetic force. म्हणजेच एखादा करंट कॅरिंग कंडक्टर जर तुम्ही तुमच्या राईट हँडमध्ये धरला असेल तर जर अंगठा इलेक्ट्रिक करंटची डायरेक्शन दाखवत असेल तर तुमची वळालेली बोटे ही मॅग्नेटिक लाईन ऑफ फोर्सची डायरेक्शन दाखवतात. यालाच राईट हँड थंब रूल असं म्हणतात किंवा मॅक्सवेल कॉर्कस्क्रू रूल असंही म्हणतात. Now we are going to learn force acting on a conductor in a magnetic field. Whenever current flows through a conductor in presence of magnetic field, a force is exerted on the conductor. याचाच अर्थ जर करंट कॅरिंग कंडक्टर आपण मॅग्नेटिक फील्डमध्ये धरला तर त्या कंडक्टरवर फोर्स ॲक्ट होतो. And the direction of this force depends on both the direction of current as well as the direction of magnetic field. And this force is maximum when the direction of current is perpendicular to the direction of magnetic field, which we are going to learn now in the Fleming's left hand rule. According to this rule, the left hand thumb, index finger and the middle finger are stretched so as they all are perpendicular to each other. Then if the index finger is in the direction of magnetic field and the middle finger points out the direction of current, then the direction of thumb is the direction of force on the conductor. याचाच अर्थ तुम्ही तुमच्या डाव्या हाताची 3 बोटे म्हणजे अंगठा, मिडल फिंगर आणि इंडेक्स फिंगर एकमेकांना परपेंडिक्युलर असतील अशा परिस्थितीमध्ये ताणले तर इंडेक्स फिंगर हा मॅग्नेटिक फील्डची दिशा दाखवतो, मिडल फिंगर हा करंटची दिशा दाखवतो आणि थंब हा त्या कंडक्टरवर ॲक्ट होणाऱ्या फोर्सची दिशा दाखवतो. या फ्लेमिंग्स लेफ्ट हँड रूलचा वापर आपल्याला इलेक्ट्रिक मोटरचं कन्स्ट्रक्शन आणि वर्किंग बघताना होणार आहे. So let us start electric motor which we are using in our daily life. An electric motor is a boon because it is used in fans, refrigerator, mixer, washing machine, computer, pumps and so many equipments. So we are going to learn how this electric motor work. But before that we will learn what is electric motor. So actually it is a device which change electrical energy into mechanical energy. So this electric motor consists of two rectangular loops of copper wire which have a resistive coating. This copper wire is placed between the north pole and south pole of a magnet in such a way that its branch AB and CD are perpendicular to the direction of magnetic field. When the circuit is completed and the current flows in the branch AB of the loop from A to B, then according to Fleming's left-hand rule, a force is exerted on the branch AB and pushes it down. The current in the CD branch is opposite direction to that of the AB branch, and therefore force is exerted on the branch CD in upward direction. And because of that, the loop and the axle start rotating in anti-clockwise direction. The current in the loop is reversed after each half rotation, and the loop and the direction uh, loop and axle continue to rotate in anti-clockwise direction. So commercial motors run on the same principle. Now we are going to learn electromagnetic induction. In the year 1831, the scientist Michael Faraday showed that the electric current can be produced in a conductor with the help of moving magnet. If the electric conductor is moving in a magnetic field or the magnetic field around the stationary conductor is changed, the electricity is produced in the conductor. This is called electromagnetic induction. This principle is used in the working of electric generator which convert mechanical energy into electrical energy. Now we will learn Faraday's law of induction. Whenever the number of magnetic lines of force passing through the coil changes, the current is induced in the coil. This is known as Faraday's laws of conduction. The current produced in the coil is called induced current. To understand when will be the induced current in the electrical conductor, that is coil, is maximum, for that we are going to learn Fleming's right hand rule. The induced current will be maximum when the direction of motion of electric conductor is perpendicular to the magnetic field. To show the direction of the induced current, Fleming's right hand rule is very useful. Stretch the thumb, the index finger and the middle finger in such a way that they will be perpendicular to each other. In this position, the thumb indicates the direction of motion of conductor, the index finger indicates the direction of magnetic field, and the middle finger shows the direction of induced current. This rule is called Fleming's right hand rule. Now we are going to learn DC means direct current and AC means alternating current. When the current flows in one direction in a circuit, that is from cell to cell, such current is called direct current or DC. And the current which changes in magnitude as well as in direction after equal interval of time, then it is called alternating current, that is AC. The direct current can increase or decrease or it can be stable also, but it is not oscillatory like AC. Alternating current is oscillatory because it increases to maximum, then it reduces to zero, and then again it increases to maximum in other direction, and again it is reduced to zero. The oscillation of alternating current occurs in a sinusoidal manner with time. Alternating current is periodic. In one cycle, it goes in forward and reverse direction. In India, in the power station generating electricity, one cycle changes in 1 upon 15th second. That means the frequency of alternating current in India is 50 Hz. That means 50 cycle per second. The home supply of electricity is in the form of alternating current. The alternating current is beneficial for long distance because there is minimum power loss during transmission. Now we are going to learn electric generator. It is a device in which mechanical energy is converted into electrical energy. The mechanical energy is used to rotate the current carrying coil in a magnetic field, due to which electricity is produced. The copper wire coil, that is ABCD, is kept between the two poles of magnet. The two ends of the coils are connected to the conducting rings, that is R1 and R2, via carbon brushes. Both the rings are fixed to the axle, but there is a resistive coating in between the ring and the axle. The axle is rotated with the help of a machine from outside, due to which the coil ABCD start rotating. The stationary carbon brushes B1 and B2 are connected to the galvanometer, which shows the direction of current in the circuit. When the axle rotates, the branch AB goes up and the branch CD goes down. That means the coil ABCD rotates in clockwise direction. According to Fleming's right-hand rule, the electric current is produced in the branches AB and CD in the direction A to B and C to D, and hence the current flows in the direction A to B, B to C, C to D. After half rotation, the branch AB takes the place of branch CD and the branch CD takes the position of the branch AB, and because of which the induced current goes as D to C, C to B, B to A. This repeats after every half rotation and the alternating current is produced. That's why it is called AC generator. If we want to make a DC generator, then the split ring is used instead of axle. Hence, the current flows only in one direction in the external circuit, and that is why the such generator is called DC generator.